Welcome to Stitchless Circle Optics in Focus. I'm Jennifer Sertle, Vice President of Marketing at Circle Optics and your host. Our hardware may be groundbreaking, but it's our software that truly unlocks its full potential, transforming raw data into real-time situational intelligence for a safer, smarter, and more immersive world. In this series, you'll meet the engineers, developers, and problem solvers really building innovative solutions that make our technology really one of a kind and groundbreaking. We'll explore not just what they've created, but really why it matters for mission critical operations, immersive training, and a safer, more connected future. This program today is dedicated to the concept from pixels to places, photogrammetry in action with Anjali Jogeshwar and Mitchell Baller, who are going to be talking about what they're doing in software development at Circle Optics. What I'd like each of them to do is to go ahead and share your name, your role, and what sparked your interest in actually photogrammetry and 3D construction. I'll go ahead and start with you, Mitchell.
All right. Yeah, so thanks for the introduction. My name is Mitchell Baller. My title here is Computer Vision Engineer, and I've been with Circle Optics for a little over 3 years now. I'd say talking about my interest in photogrammetry and 3D reconstruction actually started with computer vision as a field in general, which happened entirely by accident, actually. It was when I went back to grad school. I actually thought I was going to be focusing on operating systems and computing systems, but the first elective I wanted to take was full that semester, and so I just totally picked a random elective from the list of interesting looking classes, and that was computational photography. And that totally sparked my interest in the field of computer vision in general. And I think the reason for that is in a lot of computer science, right, it's about controlling a computer and getting it to do things that you want it to do. And in the field of computer vision, when you get a computer to do what you want, it results in like cool pictures and visualizations, and extending that on to the field of photogrammetry and 3D reconstruction, the results it gives you are like 3D immersive environments or recreations of your own world. And that's just the coolest thing. It's, controlling computers and getting them to build that sort of stuff is just so rewarding. And what I love, this is the first time, even though I've known you for 3 years, that I've heard that part of the story. And I love the fact that that it actually chose you. Computational imagery actually said, we want Mitchell to work on us to make it for the future. I love that. It hooked me, That's cool. Yeah.
Okay. So I'm Anjali Jogeshwar. My title at Circle Optics is Senior Computer Vision Engineer. I am going to complete 1 year in next 2 weeks. So that's exciting for me. I got into 3D imaging from my PhD. So my role is about making sense of what the camera sees. It's analogous to how human beings see the world through their eyes. So the eyes are camera and your brain is the processor. And I kind of make a similar system for cameras. So for them to see the world and understand the world the way we see it. And my interest actually comes from my PhD. I got my master's in human vision data processing. So it's more about modeling human behavior. And it was about human interactions in two-dimensional space. So for 3D, we were like, let's kick it up a notch. We'll add another dimension to it. And that involved understanding where human beings are in 3D space. And that understanding that space meant capturing that space. And that's how I got into 3D reconstructions, is for me to have an environment where I can see how people are interacting and simulating that, essentially. So trying to replay a capture without ever actually being present. So that's how it started. And then it started with like, let me do one model, but then half of my dissertation is about 3D models. And I just don't want to do a shout out to the Carlson Imaging Science Center. We're good friends with them, and we're excited to have a couple of graduates with us, and Anjali being one of them with her PhD. And let's jump into what is one of the biggest challenges that you face when turning raw imagery into usable 3D modeling? And we'll start with you,
Great.
Mitchell?
Yeah, this is a very relevant problem for us at Circle Optics. And part of that is because our secret sauce at Circle Optics enables us to capture a ton of pixels. There's a lot of information we can capture with a system like Hydra 2. And when we're talking about doing a 3D reconstruction, one of our biggest problems is managing all of that data. If, like I said, with Hydra 2, 60 frames per second, each frame being 54 megapixels, that is a ton of data. And when you're wheeling this camera system through a space, you might not actually need all of those pixels. And so for us, figuring out how to pick out the most relevant parts of the image, the most relevant parts of the scene has been a very sort of critical piece in this pipeline, because having enough compute to process all of those pixels is not a trivial problem. So that's something we've been working on, and another piece of the puzzle that happens because of Circle Optics' secret sauce is that the operator is inherently in the shot. Because we captured a full spherical view, if someone's out there wheeling the camera system around, you're in the shot, right? You're always in the shot.
That's right.
And so we have to sort of figure out how to intelligently pull the person out of the scene when we're trying to reconstruct it, because we don't want a million copies of Anjali walking through the scene as we're reconstructing it. So,
I love that. You have a future in marketing, because I'm now going to be using hashtag Circle Sauce.
Circle Sauce, nice.
Which will be great. And for those of you that are my age, I'm in my mid-50s, certainly a Gen X, certainly latchkey kid. I imagine Ziggy behind the system. If any of you remember what the Ziggy used to look like. For those of you, hopefully there's a little chuckle. What's one of the biggest challenges for you, Anjali?
For me, it is related to what Mitch said, because we're trying to make sense of what the world is being captured into a different space but simulated, because the way computers see data is not the same the way we see it. A lot of the things that we as human beings process really quickly in our head is motion blur. When we run, we don't really feel the blur. Like, we know we're not looking at it in sharp dimensions. And those are like finer of the things, as Mitch said. A lot of data comes in, and you got to figure out what to process and how to process. And that does stay as a challenge at all times. And it's also like, as a scientist and as an engineer, I don't want to lose the data, because data is everything for me. So I'd rather have the data and make faster processing for it than let go of it.
What is something, and I'll start with you this time, Anjali, what is something that most people don't realize about what do people don't understand about software development that will help us have a greater appreciation about what you contribute? So
software development has parts to it. A key part that Mitch and I work on is algorithm development. One part is algorithm development. It's the logic behind how the software should work. Then comes the bones, the structure, the face, and the flesh, right? When you interact with something, when you pick it up with your fingers, it's your brain interacting with the object, but it's also your skin touching it. Right? When you have a piece of software, when you click a button that says like, run reconstruction, it is that aspect of you clicking the button, which is touching with the skin. But everything that goes underneath that, that's where we come in. We come into the part that does with the brain that, I have now received the function of reconstruction. I need to do 10,000 things to make it work. And it's the same thing as picking up a cup. Your brain is doing 10,000 things, you just don't realize it.
Yeah, I love how you're trying to make some of the analogies like living systems,
yes,
which is kind of not what I expected on a technical conversation about software, but it's actually helping it be more accessible. What are some of the things that you want us to know? I'll say us non-software engineer people.
About
the work that you do. We want to have a greater appreciation about what you contribute to the overall success of Circle.
Great. Maybe one thing I'd like to touch on is the accuracy of our systems and the precision at which we operate. And a sort of crystallizing example of that is what we as a software team call calibration, camera calibration. And again, what makes our camera system special is that the sort of overlaps between neighboring camera channels is fixed. And, if you're close to the camera or far from the camera, it's the same. But it's very important for us to measure exactly where those overlaps happen after the camera has been constructed. And the process we do for that, in the software field, like I said, we call that camera calibration. And we spend a lot of time making sure that we can estimate to within fractions of a pixel where one camera ends and where the other camera begins. And so that's an underrated potentially part of what we do as a software team and how it impacts our camera systems.
That's great. You have been listening to Anjali Jogeshwar and Mitchell Baller, two great contributors to the Circle Optics secret sauce. And I'm looking forward to having you back because I feel like we weren't able to get through all of our questions in this segment, but hopefully people want more.
Hope so. Thanks for having us.
Thank you for having us.
Thank you for joining this edition of Stitchless episode, Circle Optics in Focus. And we are so proud to deliver situational intelligence for a safer, smarter, more immersive world. And we'll be back soon with more stories from the team that are really taking these ideas and shaping the future.